Okay, here's another graph, and I actually included a y-axis with this graph, but it's not necessary that I do it. This question could be answered without referring to the y-axis. I've got 2 points on the x-axis, and I want to know the factor by which y changes. Well, I can put an arrow here, and I can put an arrow, let's say here. Okay, what's the factor by which this quantity has to change to make this quantity? Okay, well, you can probably estimate that fairly easily. You could say, okay, well, there's 1, 2, 3, 4, 5. Looks like something close to 6, maybe between 5 and 6. Okay, so it looks like the y factor is 6, maybe. That's just using my fingers. Slightly more efficient way to do that is we could double the y value. And to do this, I'm going to go ahead and go over to the axis. The length of the arrow is the same as the coordinate on the y-axis. Okay, if I double this, okay, here's where I double the first y. Okay, now I could do the tripling and the quadrupling and so forth, but I'm going to double the double. Okay, so here's the doubled y value, or the y coordinate, or the doubled arrow length if you want, because you could draw an arrow this long. And I double it again. This is the doubled, which is the fourfold y value. Take the original y value and quadruple it. Okay? Now, I could go ahead and double this. Now that would take me all the way up to here. Okay? So that would be 8 times my original y value because I doubled the fourfolding. Okay? And I wanted to draw the number 8, but I'm going to change my mind here. I got to remember what I was going to say. I'm going to pause for a second. Okay. I'm going to say that this is a factor of 8. That's right here. Here the factor is 4. Here the factor is 2. And here we doubled the fourfolding, if you like. Okay, but it's obvious if we double this and the factor here was 4, now the factor is going to be 8. So we know that the factor is between 6 and 8, right? Between 4 and 8. Now what's closer? Let's see, 4 or 8. It looks like it's right halfway between, so that kind of confirms my factor of 6. Now we could, in general, if you know it's between 4 and 8, you would cut that interval in half, and then you would cut each of those intervals in half. So at this point you'd have factor 5. 1, 2, 3, 4, 5. And here's 6, 7, 8. So that using either arrows or projection lines to the y-axis, we can determine these factors. And I could have used arrows. You know, I could have drawn the original arrow equal to the original one. I could have doubled that. And then I could have doubled that. And I could have doubled that. And then I say, okay, this one is here, about halfway between this one and this one. That would make it, well, this is factor 4, this is factor 8. Okay, so Here's the original, factor 2, factor 4, factor 8. I'm not going to label those. Maybe I ought to label them. Okay. The question is, where am I going to label them? We have the original. We have factor 2, factor 4, and factor 8. Here's our factor 8. Down here is our factor 4. Down here is our factor 2. And of course, here's our original. There's no good place for me to draw that arrow, so I'm not going to draw it. You can redraw the picture if you like and make the arrows where they ought to be. Or, leave room to do the arrows and so forth. Okay, this should give you some idea how we do it. And I'm going to do one more example. Okay, here's another graph. And I've got two x values. I've gone ahead and put an axis in here. Remember, an axis is not necessary to do any of this. Now, if we're trying to solve a lot of problems, we do need to know where the y-axis is, but we don't need the y-axis for most of these. At least, we don't need the y-axis to understand what we mean by the factor and to find the factor for 2 points. Okay, so here are 2 points. Now, you might think about what you believe the factor to be. The second is less than the first, unlike here, where the second was greater than the first. So we know that the factor is less than 1. Okay, well, we'll project to the y-axis just to give us a convenient place to do this, but of course we could use just pictures of the vectors alternatively. Okay, so my first question is, well, is the second one more or less than half of the first? Okay, and it looks to me like the second is less than half the first, so here's the length of the first. Half the length of the first, well, we just come to a midpoint here. So that's half times the first. Okay, well, is it more or less than half of that? Well, half of that would be a quarter times the first. And it's between a quarter and a half, okay? So we see that the second is between 1/4 and 1/2 as great as the first. So we see that the factor is between 1/2 and 1/4, i.e., between 0.5 and 0.25. So if the factor here would be 0.25 and the factor here would be 0.5, what do you think the factor would be? What do you think the factor is here? Okay, now I'm going to leave that to your thinking. I know approximately what I think that factor probably is. The strategies I'm advocating here are, okay, if your second one's bigger, then try doubling the first one. See if that's bigger than the second. If not, then it's between, the factors between 1 times the first one, and 2. If doubling leaves you below the second one, then double again. If you're still below the second one, double again. You're not going to have to do too many doublings before you exceed the second. And then you can say, well, okay, this is factor 2, this is factor 4, this is factor 8. Now let's start narrowing it down. And if the second is smaller than the first, well, we go the opposite direction. We cut the first in half, see if that's bigger than the second. If it is, then we cut it in half again. We do that until it's smaller than the second. It doesn't take many cuttings in half until things get pretty much invisible. And so if you got two visible arrows here, or two visible y values, you're not going to have to do many halvings. Okay, so we narrow down between, in this case, between a fourth and a half. We might have narrowed down between 1/32 and 1/16. We're never going to get so far that we narrow it down like between 1/512th and 1,024th. The arrows would get way too small. And that would be accomplished in just 10 halvings. So we're going to have fewer than 10 halvings, and that's going to be completely manageable. Usually you get up to 6 or 7, and you're pretty well done. So those are just a couple of strategies for determining the factor, and this ought to be helpful in understanding what I mean by the factor, second y value as a factor of the first. Now this doesn't help you construct a graph or for example, when y quadruples as x doubles, or y doubles as x changes by a constant amount, but it does help you find the factors that would be relevant to analyzing those graphs.